a challenging problem, at least it was for me, from the 1960 IMO. This is problem 2, and I think this was the second International Math Olympiad. Now, so they're looking for the range of x's such that this inequality holds. When I first looked at this, I thought, okay, well, just determine if it's increasing, decreasing, solve this thing, you know, make it an equality and solve for x. And I realized how onerous the algebra was. Now, one thing I did to kill some time here is write down the domain. Notice that if you substitute a number less than -1/2, you would have an imaginary, like for example, if x were to the left of -1/2, say -1, you'd have the square root of -1 or I in there. So we're avoiding imaginary numbers by having -1/2 as the lower bound. And also 0 itself, if you put a 0 right here, would give you, you know, 4x squared over 1 minus 1. So you'd be dividing by 0. So these domain restrictions kind of help you, you know, when you actually solve it, you have to make sure you honor these domain restrictions as well. Now it turns out, and this is where I spent a lot of time, a substitution is probably the way to go here. There may be other approaches, but I went ahead and I called V the radical, because the radical is what causes all the problems if you actually try to expand this out, and you end up having to square away maybe more than once, and you end up with extraneous solutions. So anyway, I chose V is equal to the square root of 1 plus 2x. Now, notice that implies, let me get the marker working here. That's, if V is equal to this, then certainly V squared is equal to 1 plus 2x, right? All right. So now, again, y'all, sorry, that's supposed to be a V squared right there. Sorry, that's a V squared. Now, so that means that 2x plus 9, which is present over here on the right-hand side. That's killing me. Let me erase that. Okay, sometimes the Wi-Fi gets a little out of whack here and I can't. Let's see. Okay, so this is supposed to read right here, V squared, okay? So V squared is equal to 1 plus 2x, and that takes care of quite a bit of stuff here, because if V squared is 1 plus 2x, then 2x plus 9 is V squared plus 8, which is what will replace this. And also, V squared minus 1 would just be 2x. You see, V squared minus 1 would just be 2x, right? And so you'd have 2x squared equals to the 4x squared, which is in the numerator, right? So anyway, you probably saw that, but what that does, that turns this expression in terms of x into an expression or an inequality in terms of V, okay? Now I looked at this for a while and wondered if it was a good choice, but what really makes things work right here is to note that V squared minus 1 is the difference of 2 squared, and when you actually apply the laws of exponents, you see you get V plus 1 quantity squared times V minus 1 quantity squared. And of course, you can reverse this because of the minus sign getting canceled. And so a nice thing happens right here. These two guys right here cancel out. See right here, V minus 1 squared cancels with V minus 1 squared. And it leads to a pretty tractable circumstance. So it all works out pretty nicely from here. And so you get this inequality. Now notice, you're going, where did the 0 come from? Well, right here, V is necessarily greater than or equal to 0, right? That's just the domain restriction on the square root function. If we let V equals to the square root of something real valued, V itself has to be greater than or equal to 0. And so that's where this 0 right here comes from, just a domain restriction. It's easy to forget that and just leave it out. And then it all just works out pretty nicely here. We have to get it back in terms of x. And so from here to here, I just replace V with what it's equal to, okay? And then after that, it's fairly direct. We square this entire inequality to get this to this inequality. And the rest of it is just getting everything on the proper sides. Subtract 1, subtract 1 from 49 over 4, you get 45 over 4. And then divide by 2. And it's tempting to say this would be the answer. But remember, this is the domain restriction right up here. This is the domain restriction. No solutions can fall outside of this domain. And so we have to tickle this just a little bit. And effectively, we replaced it infinity with 45 over 8. Okay, folks? So this expression is less than this linear function from -1/2 all the way out to 45 over 8, excluding 0. So the power of a substitution, what do you know?